Vocês estão sendo transmitidos em YouTube,
sim,
canal para o Brasil inteiro, para o mundo inteiro. Yesterday, Shell in Houston, I have some feedback. The guy makes some meeting to receive some exploration perspective, another panel. But in the end, if you could call some word for the new generation of science, different universities in Brazil or abroad, how is important this domain, use this channel in the end to pass some message for the young generation. I think it will be fantastic.
Okay.
Go ahead.
Thank you, Paulo. Okay, good morning, everyone. Thank you all for joining us here at the Brazilian Geophysical Society Conference. My name is Alexandre Ferreira from SEMPES, Petrobras, and I have the honor to moderating this morning's technical panel and special session titled Geophysical Frontiers in Hydrogen Exploration, Bridging Mineral and Petroleum Systems. Over the past few years, geologic hydrogen has been drawing the attention of geoscientists and energy professionals from around the world due to its significant energy potential and the possibility of contributing to the lower carbon economy. In fact, just last month, the AgeNet conference, an annual meeting dedicated to topics related to geologic hydrogen, brought together more than 650 participants from multiple countries. At the same time, more than 200 scientific papers on geologic hydrogen were published in 2024 alone. And several companies are now drilling wells specifically designed to explore geologic hydrogen resources. However, the application of the right geophysical tools and the full interpretation of geophysical data in hydrogen exploration remain challenging, especially due to the high reactivity and diffusivity of hydrogen in the subsurface. We need to ask ourselves critical questions like, how can the legacy of oil and gas industry help us? Is there a hydrogen system per se? If so, how can geophysics evolve to support hydrogen exploration? Would these approaches apply to hydrogen production through stimulation? And what lessons from the mining industry could be adapted to hydrogen exploration, including regulatory frameworks? To introduce these topics and engage the audience with a solid foundational understanding, we are honored to welcome Humberto Reis, founder and director of HSR Consulting Energy and Geosciences. Humberto will deliver a 20-minute keynote presentation providing an overview of geologic hydrogen, covering the basic concepts, fundamentals, properties, and key challenges for hydrogen exploration. This will give us a common language and foundation as we move into our more specialized panel discussion. To deliberate on these crucial questions and dive deeper into the technical details, we have also assembled 3 other distinguished experts, recognized both nationally and internationally for their pioneer roles in advancing sustainable hydrogen economy initiatives and contributing to the diversification of Brazil's energy matrix. Together with Humberto, they represent diverse perspectives from industry, academia, and specialized consulting that will help us bridge the gap between mineral systems, petroleum systems, and hydrogen exploration. Let's welcome our distinguished panelists to the stage. So first, I'd like to call Professor Rômulo Conceição from the Institute of Geosciences, Federal University of Rio Grande do Sul. Please. Professor Alain Printzhofer, Scientific Director of Geo4U, Professor at the Federal University of Rio de Janeiro, member of the Scientific Board of Laboratório Interdisciplinar des Energies de Demain. Did I mention correctly? Welcome, Alain. Omar Maiga, please, founder and chief scientist of AgeNet Consulting and Engineering. Welcome. And of course, Humberto Reis, founder and director of HSR Consulting Energy and Geosciences. Welcome, Humberto. Acho que eu vou ficar aqui, se puder ficar na outra. Here is how we will structure our time together. First, as mentioned before, Humberto will provide a comprehensive overview of geologic hydrogen fundamentals. Then our four panelists will introduce their specialized perspectives, followed by my targeted questions on specific topics, and finally, we will open the floor for questions from the audience. So I encourage you to engage actively throughout. Please have your questions ready, and at the end of the session, we will have time to address them, hopefully. This is your opportunity to learn from the best in the field and to contribute to shaping the future of hydrogen exploration geophysics. Well, without further ado, let me invite Humberto Reis to the stage. Well, he is already here for our general overview. So, Humberto, like 20 minutes presentation. Pessoal, se puderem colocar a apresentação do Humberto aí. Ok. Microphone is working.
Oi.
Okay. Go ahead, Humberto. Thanks for joining us.
Oi. Well, good morning, everyone. First of all, thank you for the space. Thank you for the invitation. It's really a pleasure being here with you discussing this important subject, especially in the middle of the energy transition. I think that natural hydrogen is emerging as a future natural resource. But we still have many questions. We do know many things about natural hydrogen, but we still have many questions. So the idea here is just to present an overview of what we know, and mostly about the questions we still need to answer, just to start the discussions today. Okay. Well, let's start from the beginning. The natural hydrogen, or the hydrogen, is an important element in the history of cosmos. Together with a cloud of dust, it was the main element that occupied this place, this area, which is our solar system today. Around 4.6 billion years ago, this cloud collapsed due to the gravity. The existing hydrogen combined with other elements to form large amounts of helium. At the same time, our sun ignited and the planetary system formed. The natural hydrogen in planets like Earth combined with other elements to form more complex compounds, and part of it was lost from our atmosphere due to its small size and also its reactivity. Today we have just trace amounts of natural hydrogen in the atmosphere. We see here some values. And this is the history we used to tell along the last decades. But a series of discoveries have changed this scenario. A series of discoveries of natural hydrogen preserved in the crust has shown to us that natural hydrogen could really be preserved and eventually form large accumulations. So possibly the main discovery that changed the scenario is represented by this well you see in the screen. This well was drilled in Mali. Here we have two specialists on the subject. I think that they will discuss a little bit more about it. In the 80s, a well was drilled for water, but for some reason this well found a gas. A few hundred, maybe 100 below the surface, 100 meters below the surface. And a few years ago, a small company called Petroma started to evaluate the economic potential of these gases. At that time, they drilled other wells and they analyzed the gases and discovered large amounts of natural hydrogen. Actually, it's a very pure gas with more than 90% of natural hydrogen. This gas was produced, and then it started to feed a small power plant that was constructed locally to give for the first time the electricity for a small village in Mali called Borakebogu. Well, different discoveries were reported in the world. Most of them are actually the reassessment of old data we knew before from hydrocarbon wells, mining wells, and also water wells. And then at some point, natural hydrogen occurrences of natural hydrogen were already reported in almost all continents of the world. So the subject started to be considered one of the main scientific subjects of the decade. And we see here many reports and many different informations in the news and also scientific papers that started to appear along the last years. This discovery is also started to give some gas as well for other areas of the science, including the space exploration, since the natural hydrogen systems are prone to represent maybe the cradle of the life in the Earth, and thus they could give us some idea of how and where to find life in other planets. So this subject started to change many things in the science. In parallel, we have been facing a problem you all know well, which is the global warming. Here we see an animation showing the change, the temperature anomalies since the industrialization of the world. So we see in the warm colors here are hotter, and the bluish colors are colder. So we see that since then the temperature is changing. This map is becoming more and more red or hotter. In 2023, the world was about 1.36 Celsius degree hotter than the pre-industrial temperature. So this led to many countries to decide change things in a way. It started with 55 countries that signed an agreement that lately was called Paris Agreement. These countries represented at that time about 55% of all CO2 emissions to the atmosphere. That has caused this change in the temperature. So this Paris Agreement actually is it comprises several different ways or strategies to reduce the emissions of CO2 to the atmosphere and then try to control this temperature increasing. The idea was to keep it below 2 Celsius degree, but actually it seems that things are not so good anymore, so it seems that we will not be able to do it, but we are still working on it. And the hydrogen has been used in different industrial sectors along the last decades, but all the hydrogen used today is generated through industrial processes. So it means that we have many sources of hydrogen that can be expensive, and other sources that are cheaper, but they are terrible in terms of emitting CO2. So these different types of hydrogens generated through industrial processes, they comprise the so-called hydrogen rainbow. Each color you see here actually represents a different process that is used to generate the hydrogen. Well, so we see that in these conditions, the natural hydrogen received a growing attention because the natural hydrogen changes a little bit this rainbow there. We see that the natural hydrogen, according to our expectations, could be something cheaper and also emitting lower amounts of CO2 to the atmosphere. So here, if things works, we are dealing with something that can really change the scenario of the energy transition. All these elements, for these reasons, led to the beginning of the exploration of natural hydrogen along the world. This map, I used to say that this map is always out of date because each day we look for the news, we see a new company exploring a new place. But anyway, this map is able to show us how the world is looking for the natural hydrogen. Here we see that there are companies in almost all continents trying to not only to understand the system, natural hydrogen system, but also explore it and have and try to make it economic. But what is the natural hydrogen? Natural hydrogen, in its simplest definition, is the dehydrogen that is formed under natural conditions. Today we know that the natural hydrogen can be formed by different processes. We are studying different ways that these gases or complex compounds may migrate in the surface or even accumulate. But in the simplest definition, we can consider that is the hydrogen formed under natural conditions. Today, we still, as I mentioned before, we still have many questions, open questions about the natural hydrogen system, but here we see a few elements that we also know at least a little bit about it. And other elements we are still trying to understand a little bit more. So here we see that there are different sources that are able to form the natural hydrogen in the nature through different chemical pathways. Most of the sources are associated with iron-rich rocks, and the processes are associated with the water-rock interaction. So when we have iron-2 in the rock, it's possible to, during reactions with water, to form the natural hydrogen that comes from this water through the oxidation of this iron-2. The other process, important process here is the radiolysis, which is able to split the molecule of water in the subsurface and then release the natural hydrogen for the system. We still don't know what happens after the formation of this hydrogen in the crust, and we still don't know if we have indeed seals, efficient seals for retaining large amounts in the subsurface. But we are looking for it. Here we see an example, maybe one of the most iconic examples of natural hydrogen forming in the nature. This is a field which is called Chimera field. There are gases in this area that has been emitted through thousands of years. And these gases are associated with these eternal flames there. Actually, these gases are composed by a complex mixture that includes hydrogen and also abiotic methane. And here we have gases, at least in part, formed through this interaction between these Cretaceous ophiolites in Turkey and water, which can release this hydrogen through different reactions that are shown there. The methane associated with this hydrogen is probably formed by the interaction of the hydrogen formed in the system and also the CO2 available in the system. There are some reactions here that can also form this abiotic methane. Here we see, we still do, based on lab experiments, we have different rates of generation for the natural hydrogen. We are still trying to understand these rates in the nature, but today we know that the temperature is a critical factor controlling this generation of hydrogen in the through this serpentinization reactions. Here, just to have an idea how the natural radioactive decay can form hydrogen through the splitting of water in the system. By forming the hydrogen, the radioactive decay can also form some helium, which is also important in terms of economicity for many projects worldwide. Today we know possible reservoirs that can store this hydrogen in nature. The examples in the literature show us that sandstones, carbonate rocks with higher or lower porosity and permeability can store this hydrogen. Fractured siliciclastics are also examples that also can store this hydrogen, and other types of natural reservoirs that have been pointed in the literature. So maybe one of the most famous elements of these systems are the so-called fairy circles, which are small depressions in the surface that for some reason emit hydrogen in different rates, in different amounts, year by year in the surface, and they are probably the end way of a long way of migration from the source rocks to the surface. These are elements which are still being studied in the literature. The natural hydrogen can be formed in different geological settings, from the continent interior to the boundaries of the plates and cratons in different areas. We just need to, it seems that we just need to have the right ingredients to form it, and then the natural hydrogen will be formed. It's interesting, something is interesting, because the natural hydrogen seems to represent for us a kind of hybrid hybrid system between the natural, between the hydrocarbon system and also the mineral system. Since most of the source rocks are associated with the basement in many cases, we are dealing with geological components that are host rocks for different types of mineral deposits. But after formed, it seems that this natural hydrogen tend to follow paths similar to the hydrocarbon systems, especially natural gases. Well, but as I mentioned it before, we still have many questions, open questions to be answered, and I think that these questions will be treated in this discussion here. I just separated a few of them, some which I think are more important, that include what sources, and we know many sources and processes, but which one of them can produce natural hydrogen in an economic scale? The other question is, are natural hydrogen systems dynamic and short-term or long-term systems? We are still discussing the possibility to form the hydrogen and preserving the geological time. The problem is that the hydrogen is too small and very reactive. It means that it's quite difficult to preserve it, but it's possible. Which mechanisms control the migration of the natural hydrogen in the crust? Since it's also small and very reactive, we are still discussing if the mechanisms are most associated by advection or diffusion or a combination of this. Do the natural hydrogen migrates in the form of bubbles, aqueous solutions, or in its gas phase? It's also an important question to be answered. Are different seals, are there efficient seals for preserving hydrogen through the geological time? Again, the problem is the size of the molecule and also its reactivity. Here we have a new question to answer. What is the whole role of microbial activity on the preservation and consumption of hydrogen? As I mentioned it before, there are many organisms down in subsurface that consume hydrogen to live. So it's possible that there are cases in which the hydrogen is formed, but it's not possible to accumulate because the microorganisms will consume it. It is possible to produce natural hydrogen in economic scale. This is the 1 million question. But we still need to know the flow rates of wells. This is a critical question that is still open. Can we consider natural hydrogen system as a hybrid mineral hydrocarbon system, as I mentioned before? And finally, are we prepared to produce, transporting, and storing natural hydrogen? Many things will occur after the production. We need to be prepared. And finally, maybe the most important question for this meeting here, what is the role of geophysics in the emerging natural hydrogen exploration and production? So I think that here we have many questions to start this discussion, and I finish this presentation here. Thank you very much.
Thank you very much, Humberto, for this very comprehensive presentation. I'll welcome you back to the stage. Okay, let's start our discussions, but I would like to start with a quick round of presentations, like looking at the past. What's your story with hydrogen? Why are you here? Like 2-3 minutes, just for the audience to know what kind of work you're performing. We can start with Alain. See if the microphone is working.
Does it work? Yeah. So I'm Alain Prinzhofer. I'm a geologist and geochemist. I worked on both the academic research and applied research on different fields. In fact, a long time ago, I worked with ophiolites and ultrabasic rocks. I forgot that, but now it comes back because of the hydrogen exploration with ultrabasic rocks. I worked a long time in oil and gas research, mainly gas, hydrocarbon gases. And now I'm really devoting my time 100% to natural hydrogen exploration, understanding, and in different parts of the world.
Okay, thanks, Alain. Omar, how about yourself?
Yeah, thank you very much. So I'm Omar. I've been working on mining sector before joining natural hydrogen history, thanks to Alain, who contacted me after my master's degree. So I used to work on the Malian field, which is the only places, as Humberto says, where natural hydrogen is accumulated and used for electricity. So I did a PhD on these natural resources at IFPEN, French Institute of Petroleum and New Energy, in partnership with Hadrema, who made the discovery. So now I'm working on exploring natural hydrogen in Africa and also developing countries with my consulting company, which is looking for natural hydrogen and to make it accessible and to make some discoveries that can change the paradigms on the natural hydrogen. And I'm also a researcher and working at Texas Tech University as principal investigator for geologic hydrogen there. So,
okay, thank you so much. And last but not least, we have a different kind of hydrogen over here. Romulo, talk about your kind of work and what you do so far.
Yeah, first of all, I'd like to thank you for the invitation to be the panelist here, and thank you everybody to be here. My base is in geology and geochemistry, and I developed my research in experimental petrology and geochemistry. First of all, I was working with the volatiles behavior in the mantle conditions, high pressure conditions, and we set up this high pressure laboratory in Brazil, in the south of Brazil. And due to the meaning of this subject, we decided to move a little bit further to work with the hydrogen and CO2. So we've been working with lower pressure and high pressure, making some experiments in CCUS, carbon capture and sequestration and usage or whatever. And by accident, we produce a lot of hydrogen, so why not work with the hydrogen as well? So that's what I've been in currently, and that's it.
Okay, thank you so much, Romulo. And before we dive into the discussions regarding geophysics, I would like to ask some more general questions first. The first one to Alain. What is the characteristic time of natural hydrogen accumulations? Is it short, like human time, or long, geologic time, or both? Is this a renewable resource? It's always a question that comes up in every conference that I attend, for example. And can we think really about a hydrogen system? What's your opinion on these topics?
Well, that's a very important question, which was already addressed by Umberto. And let's say that the scientific community working with natural hydrogen systems today is not completely converging on a simple, single answer about that. And of course, it has an interest in terms of knowledge of hydrogen, but also an interest for the business. When you produce a hydrogen accumulation, will it be possible to produce forever because it will be renewable, or will be just emptying the bottle after a while? And well, we have different constraints about that, different opinions. I would say that maybe the answer in the future will be, it depends. In some cases, it seems clearly that hydrogen is renewed with a relatively short time span, meaning human time, years. For example, the Malian case, Bouraké-Bougou, where hydrogen has been produced. What we have seen during this early production, that the pressure of the wellhead was sometimes increasing, whereas you remove hydrogen from the accumulation. So clearly, there is a refill of your accumulation. That's absolutely clear. In some other cases, it's not so clear. We have also a lot of us trying to estimate the hydrogen flux, which is generated out of a source rock, either from experimental studies or from geochemical surface measurements, where you see the flow of hydrogen seeping out of a soil or of a ground. And it seems that the values are quite high. This goes in the direction of renewable hydrogen. And as Umberto said, hydrogen is extremely mobile, it's a small molecule, and extremely reactive, chemically speaking. It's always difficult to imagine, for example, in the Malian case, you are at a depth of 100 meters, and you have an accumulation of hydrogen, 98% of H2. How can you expect to keep this accumulation for geological times, million years? We know that we have biological activity, and hydrogen is the first source of energy for biological activity in the subsurface. So clearly, it indicates that hydrogen arrived, let's say, yesterday in the accumulation. Is it always the case? Probably not. In some cases, I'm thinking about the Amadeus Basin in Australia, where you have hydrogen and helium, and which is very well sealed with evaporites, with halite. And in this case, probably these accumulations which have been demonstrated are more fossilized thanks to the halite seal, also because of the salt which will reduce the bacterial activity. And an interesting point is that in this case, the hydrogen concentrations are much lower than in Mali, where it seems to be a dynamic system. So possibly in this case, you have a kind of old hydrogen accumulation which has been diluted in other gas compounds like nitrogen and helium. The helium concentrations are very high in this area. They are very small in Mali. That's also an indicator of the kind of time you expect, because helium has to accumulate very slowly. If you consider the generation of hydrogen through radiolysis, it's a process which does exist, but it's a very slow process. To imagine that you have a hydrogen accumulation thanks to radiolysis, it would mean that hydrogen has been generated for a very long time and preserved for a very long time. So really, that's different key issues indicating that we are not converging on one single answer, and probably, depending on the geology, you will have a renewable and active hydrogen system or something which has been fossilized in the past.
Okay. Thanks for the answer. Very complete. Romulo, switching gears to the stimulated hydrogen. So you simulate nature's work in the lab, right? What are the main ideas behind these experiments? What are the optimal experimental conditions, reactants, pressure, temperature, for example, for the hydrogen production?
Yes, I'd like to take the thing that Alan was talking to us, because it depends on the pressure of the process itself. So what we've been doing is trying to simulate the Earth inside of the laboratory. That's a little bit tricky, because you can control just everything, but you need to control everything, trying to mimetize the nature itself. So as Alan was telling us, for example, we've been trying to focus on two kinds of conditions. The high pressure conditions, that means, okay, all of this hydrogen that Humberto was telling us that the Earth trapped inside, it's going to be the gassing via the time of the Earth evolution. So then it could be a very geological time, for example. You have to release all of the hydrogen, and then this releasing must be a little bit slowly, and you have to understand this better and try to understand the results of this releasing. For example, we've been trying to understand the solution of the hydrogen in the glass, for example. So once you understand the solution of the hydrogen in the glass, then you understand the solution of the hydrogen in the volcanoes itself. And the deep volcanoes, for example, probably, if you think a little bit very fastly, you could think, okay, if you go deeper in the Earth, probably you have more hydrogen because the Earth, the gassing better in the surface compared to the inside of the Earth. If you go to helium, for example, helium isotopes, you have more helium-3, the ratio 3:4. It increases once you go deeper in the Earth. So if you associate helium with hydrogen, probably if you go deeper, you have more hydrogen. However, in order to this hydrogen be released from the mantle, it has some conditions. And then we're trying to stimulate this condition inside of the laboratory. What's the best condition? What's the best environment? What's the best tectonic environment? So that's the one part of this. The other part that I think, and I agree with him, that's the human lifetime. We have all of this alteration of the rock itself. So serpentinization, whatever, any kind of alteration, if the rock has some kind of elements that can change the valence, if it can be oxidized, then it can expose electrons to have this sort of electrolysis, the natural electrolysis being currently occurring during this process. Then Humberto showed us about the serpentinization and whatever. So we're trying to mimetize this as well. And for example, we're trying to understand the kinetics of the hydrogen production using different kind of rocks. You've been talking about the peridotite, but that's not the real case in Brazil because there are not available sort of lots of peridotites in Brazil. You have this huge serpentinization, so everything's serpentinized, whatever, but it's still, okay, in the serpentines and the basalts and the iron-banded formation, for example, still have irons to be oxidized. And I believe that's then you can try to understand this better in the laboratory about this possible production of the hydrogen based on this kind of reaction. What has been observed, I was just looking at the production that we've been observing, for example, in the last experiment that we've been doing, we produced sort of 2 kilos of hydrogen per tons of rocks using basalts, for example. I don't know if it's huge or if it's small, but you need to investigate this. And also, you need to understand what's the best condition. So high temperature, lower temperature, high pressure, lower temperatures, what's the input of energy that you have to create in terms of plants, for example, industrial plants, or going to the field or digging the hole and put the water inside? What's the cost of this investment? And what's the cost of the hydrogen that's going to be produced by these conditions? So it's a very tricky question. We need to keep going, and then probably you have an answer.
Sure, that's why you are here. You are helping us with that.
And that's why we're inviting everybody to jump into the subject. Yeah,
okay, thank you. Going a little bit towards the topic of the panel here, I'd like to ask questions to Humberto and Omar now. According to McQuaig and co-workers in 2018, there are several key differences between mineral and petroleum systems. For example, petroleum systems involve a mass trapping process with the transporting fluid as the commodity, whereas mineral systems involves mass scrubbing processes with the transporting fluid having low concentrations of the commodity, thus requiring much fluid throughput. How do these concepts could be applied to hydrogen exploration? Is there really a hydrogen system, again, this question? And also, which tools from both from both approaches should be applied for the prospection of hydrogen?
Yeah, thank you very much for this question. I think all the technologies that has been used in the past for exploration can be adapted to geologic hydrogen as well. And for many mining part, I think that one of the elements or geophysical exploration method we are using can be the spectral gamma, which is for just the subsurface part. And another geophysical methods that can be interesting and useful that was used in the mining or oil and gas industry that can be also very promising for geologic hydrogen, natural hydrogen is a seismic also, but this is very, very, very expensive for this exploration type. So I do believe that these methods will still be useful for the hydrogen exploration, as it was done in Mali with gravimetric and also all the geophysical data acquisitions. They all bring to the hydrogen exploration and system some understanding of the whole system. So yeah, this is what I can talk about this. So.
Okay. And maybe, Humberto, you can complement by adding a couple of things here. What are the biggest cultural or workflow differences between mining and petroleum geophysics, and how can then be bridged? Are there examples where blending mining style geophysics and with petroleum style interpretation significantly improved the results?
Well, this is a trick question and very complex. This is a good one. Well, here we have two points, important points: the concept and the techniques. Well, about the concept, it's quite difficult to do not see the natural hydrogen system as this hybrid system, as I mentioned it, between both definitions you mentioned it, because we are dealing with, for instance, if we are exploring the natural hydrogen in a sedimentary basin, it's impossible to not deal with the basement as a source. In the same way, in the other side, it's also impossible to not deal with the sedimentary covers as seals and reservoirs. So in terms of concept, it's also impossible to not use both concepts to understand the natural hydrogen system. So, for instance, if we are exploring, today we have, in terms of economic, we have two main possible ways to form, that has been considered in the literature, possible ways to form the natural hydrogen is through the water-rock interactions, as I mentioned it before, especially the serpentinization, and through the radiolysis. So if you are looking for rocks that can be serpentinized, you are looking for the same rocks the minor industry look for, find different types of metals and other resources. So applying the techniques to explore then should follow, at least impartially, the methods and the same ideas that the mining industry used to use. For the other side, on the other side, as I mentioned it before, if we are looking the distribution of a good natural hydrogen reservoir within the sedimentary cover, we need to understand the sedimentary architecture of those covers, the lateral distribution, the interaction between these sedimentary successions and also the faults and other tectonic elements associated there. So here again we have concepts that are common in the oil and gas industry, so we need to apply both concepts and also the techniques. About the techniques, we need, I think as Omar mentioned it, almost all the techniques we use for both industry, we can adapt. We just need to understand how natural hydrogen will behave, or the system as a whole is different. For instance, the magnetometric surveys are useful for finding ultramafic rocks. But if these ultramafic rocks are partially or serpentinized, they can form or not magnetite. So it means that we need to use this data considering the ways that the path that rock followed after its formation. If we are dealing with seismic sections, we also need to, there are different techniques to evaluate the fluid migration pathways and evaluate the fluids in the formations. But in this case, we are talking about the natural hydrogen fluid, so we need to change the mind and adapt the tools in order to understand this. But in the end of the day, I think that all concepts will converge in the same place, and all techniques can be, and technologies could be adapted and used for this.
Okay. You quickly mentioned something that has to do with my next question to Omar again, because regarding these existing geochemical or geophysical methods, what could be the key geophysical signatures that distinguish natural hydrogen systems from other subsurface fluids? Do these methods need, like it was mentioned, to be modified, adapted for geologic hydrogen exploration? What modifications are required for existing oil and gas geophysics workflows to improve sensitivity to hydrogen accumulations?
Thank you for this question. Of course, it needs to be adapted because even if you found out some bright spot from the seismic data, it's very complicated today to distinguish natural hydrogen from methane, for example, because the density is more or less the same. Even if with the development of AI and machine learning, we can try to do this kind of thing, but it's still not very easy to distinguish natural hydrogen from another gas using the seismic or another geophysical data. But I think for this kind of understanding and also distinction of the gas, the seismic data are the most promising for this kind of works, yes.
Then I can give it back to Romulo, because I was curious, which rock properties that you measure in the lab would correlate with the geophysical tools commonly used in the oil and gas industry?
Yeah, currently, because depending on the kind of experiment that is being performed in the laboratories. Currently, we are doing some experiments with using powder of the rock itself. So we propose that you have the more possible surface area in order to understand the reactivity of this liquid with the rock to produce hydrogen. However, when you go to the, for example, if you think about digging the hole and putting the water inside and see what happens if you can produce hydrogen or whatever, you need to understand about the porosity, permeability. So we want to, you have this other part of the group that will work with the petrophysics. So trying to understand the permeability and surface area in order to understand the reactivity of this material. One result that's very interesting to us is the role of the clay minerals, for example. We've been discussing before, if you think about these clay minerals in terms of petroleum system, you can think, okay, they can be the ones that will drop down the permeability because they expand, and depending on the clay minerals, they do different kind of stuff. However, when you try to make these reactions, the clay minerals react better, and once they have a kind of iron, they produce lots of hydrogen, and they produce lots of divalent cations in order to trap, in order to grab the CO2. So the best results that have been observing is that we can combine, based on the dissolution of some clay minerals, the two things that's very interesting, the capture of the CO2 and production of the hydrogen as well. But depend on the clay minerals, depend on the chemistry of the clay minerals, depend on the crystallinity of this. So that's the petrophysics. I think that is nice. But from what I've been hearing here, I think that, for example, you are in the geophysics symposium, and maybe you need to look at the hydrogen indirectly, not to the hydrogen itself, because as Omar was telling us, it's very difficult to understand the density or whatever. It's very difficult to, I keep thinking that you have to drop the, sorry to say that, guys, but I think that you have to drop a little bit the oil system and think in something else. For example, in the geophysics, I think that we need to work indirectly. What's the production of the, if the hydrogen was produced once, what was left behind? So probably the magnetite, so you can use magnetometry, whatever, probably they increase a little bit of the density or decrease a little bit of the density if the rock is peridotite, and then it's going to be oxidized and then produce a lot of oxides. What's the difference of the density in between a rock that's fresh and another one that's altered? Because in between them, we have the production of hydrogen. So as you are in the geophysics symposium, I think that you need to go a little bit further, not trying to find the hydrogen itself, but trying to find what was left behind, something like that. So from my perspective, I think that's going to be interesting.
Okay, want to complement? Oh, okay.
Maybe a comment about what I don't know, geophysics. I'm a geochemist, but we are. Let's try to speak about what I don't know so well. I think hydrogen exploration is an opportunity to expand all the fields of geophysical studies compared to the oil exploration. You know, the king technique for oil exploration is a seismic reflection. Okay, great to have geometry of your systems in 2D, 3Ds, etc. When you look at hydrogen, it was said the two key components are water and iron. Iron is heavy, so gravimetry may be of some use to see if you have some anomaly in iron amount in some areas. But iron is not enough. Iron, if it's completely oxidized, won't generate any hydrogen. You need reduced iron. Then presence of magnetite. Magnetism will be interesting to use. Let's move to now the waves, the seismic waves. A lot of people speak about passive seismics for hydrogen. In the oil and gas exploration, passive seismic was not used so much. And it makes sense. You don't have beautiful geometrical image with passive seismic. It's better to use your emitters with active seismics. But the advantage of passive seismics, you can see fluid movements in the subsurface. When you look for oil and gas accumulations, you don't care because the movements are so slow, they are geological, and you won't see anything with passive seismics. If hydrogen is alive, as we discussed before, in this case you have a dynamic migration at human time scale, and passive seismics begins to be as useful as active seismic, which is also, of course, important to define the geometry. So this expansion of all the geophysical tools are, I think, an opportunity. It has been done in a lot of universities and academic world. Now it may be used for practical hydrogen exploration.
Okay.
Yes, to complement that, I think I agree with you. And most of the blinded method we are using now for hydrogen exploration is also using the VP and VS to see the rate of serpentinization of the rocks, to also try to evaluate the amount of hydrogen that could be generated based on these signatures. So yeah, I agree with that also.
Okay, and speaking about geophysical tools, Alain, gamma spectrometry, its correlation with hydrogen seeps, expressed, for example, by the presence of so-called fairy circles. Is there always a correlation between hydrogen seeps and thorium anomalies? And what can that tell us about the differentiation between radiolysis and superficial processes?
Well, it's true, it has been observed that when you have hydrogen seeping out of the ground, at the superficial level that you measure through gamma spectrometry, there are thorium anomalies. In crystal environment, I'm not speaking about ophiolite because the thorium concentrations are too small and you can, maybe there is an anomaly, but it's very difficult to define. But in crystal environments, it's true. And this is extremely puzzling because we don't have the good explanation for that. The association with hydrogen seeps and thorium anomalies are quite strange. And it is an observation which has been now done in a lot of continents. But why? And of course, as radiolysis is considered as a possible source of hydrogen, if you have too much thorium, you will have more radioactivity and more radiolysis. I'm not believing that so much because, again, we are mixing something which is related to the kitchen of generation of hydrogen, which is deep, where you would have possibly radiolysis, and this very superficial measurements of thorium. For the moment, we use gamma spectrometry in a very practical way to better define the areas where hydrogen is seeping out of the ground. Why? Because hydrogen seeps, we know it's very difficult to measure. You measure hydrogen in soils, but you may have artifacts. It's not a constant flow, it's with pulses. So when you are visiting a place, you never know if you are at the right time to measure hydrogen, or if you measure hydrogen in soil, is it real natural hydrogen or is it an artifact? We have methods to distinguish, but it's quite complex. Associating that with thorium, which is of course much more stable through time. When you have thorium in soil, it would not change in 2 hours. In this case, you have a better control of the areas where hydrogen is seeping. But for the moment, again, the interpretation and the understanding of that is at ground level. And I'm not sure it's possible to consider that it's an evidence of the importance of radiolysis, because we are not at the same level in terms of geology.
Okay, thanks, Alain. How about Humberto taking the next one? Or you have many comments on that?
Let me make some comments on that.
Okay.
We were it's because, I don't know, maybe 2 days ago, 3 days ago, we were discussing about it. This fairy circles, they are curious geological elements for many reasons. They not only for emitting the hydrogen. There are a few cases we explored in which some hydrogen was measured in surface. If I'm not wrong, the guy that measured is here. Well, so the hydrogen is there, is emitting there. And we decided to complete the study of this fairy circles, but not measuring hydrogen, but describing the distribution of the sedimentary units on the surface, the correlation between these sedimentary units with the gamma spectrometric signals. And what we found in the cases we studied is that these fairy circles, in terms of sedimentary systems, they represent very small lakes. They sometimes are dry, sometimes they are fluid. And when you look for the sediments, you see fluvial sediments around it because they are depressions. When you go to the interior of these fairy circles, you find deltaic systems with sands, and then when you go to the interior, to the central portion, you found mostly clays and associated sediments. So when you make the radioactive survey, you see the chains following the distribution of the sediments in the surface. And it seems that these areas where you can find higher concentrations of hydrogen are associated with the boundaries where you have more sands, more pores, more higher permeabilities. This is not a conclusion. These are just some ideas we reached after this investigation. So I think that it converges with, in many ways, with Alain mentioned it before. It seems there are things which are occurring on the surface and things that are occurring down there. For some reason, they are connected in this case. So I think it should be considered.
Yeah, well, that's very interesting that the sandy area is with these thorium anomalies, and it's puzzling more that this is another observation. Out of the fairy circles, we find also hydrogen seeping in big faults. And also, and in this case, there is no clear sedimentological evidence of variation of rocks. And we have also where hydrogen is seeping along the fault some thorium anomaly, which again is not explained. I'm not able to explain that. It's just an observation that we do, and why we have, of course, we're extremely imaginative, we have some interpretations of our mind, but absolutely no constraint to know exactly why we would have this correlation.
Maybe minor changes induced by the hydrogen in this is similar to the natural gas. There are changes in the soil composition. I don't know. Open questions.
Yeah, open question. I always say I'm dreaming, maybe someone in the audience may do that, somebody measuring traces of thorium hydrogen alloys. And I know that out of geology, it's quite easy with methyl thorium, which of course is not geological, with hydrogen to make this kind of alloy. How's it in English? Hydrates? Anyway, I wonder if in these soils where hydrogen is seeping and you have always some thorium around, if it would be a chemical link between thorium and H in order to generate that. I have absolutely no proof about that because I never found a lab which would be able to measure, of course, ppms of this kind of alloy in soil samples. But if somebody has some ideas, that would be a test which would be interesting.
I think Romulo will add something here.
That's great, because from my point of view, what we've seen here now is that the hydrogen that was predicted depends on the process itself. I keep guessing myself from what you are talking about here is, okay, the hydrogen was moved to the same place that the thorium was moved to, or the hydrogen could be produced by the thorium degradation and blah, 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 blah. In terms of time scale, I prefer the first one. Yeah, that's it.
Well, I don't think there is a genetic link between this hydrogen seeping and the thorium anomaly we see at the superficial level of the soil. Maybe I'm wrong, but I don't think they're linked genetically. I mean, if they are linked, it's because possibly there is a chemical effect. We were thinking about also the excess of thorium would be linked to the removal of other major compounds. And then, like in kind of lateritic or accumulations, you are not accumulating nickel, you are removing silica, and the nickel concentration is going above. Is it the same with thorium? Because of hydrogen, you have some chemical reaction, and some of the elements of the soil are leached out, and you have a higher resulting concentration of thorium. We have all these ideas in mind, but again, nobody today is able to understand.
If you'd like, you can test this for you. I couldn't get this.
We can talk about this
really,
after the panel.
I'm ready to give you some soil samples and to give it to you. And if you can see something, that would be really a big advance for hydrogen exploration with superficial studies.
Okay.
I couldn't take the chance, so.
Okay, guys, let's talk about risks now.
Sorry about this geochemical discussion.
No problem.
And geophysical.
It's interesting. I will be part of this too, by the way. Well, talking about risks. Recently, the Hydrocarbon National Agency from Colombia showed results from some stratigraphic wells. I think it's HNet, right? Specifically designed to better understand the geologic conditions that favors generation, migration, and accumulation of natural hydrogen. There is also this first natural well drilled in China and others to come. Maybe my first question would be to Omar. Acquiring geophysical data can be a very challenging step for smaller companies. In your view, what's the single most expensive or with higher risk geophysical data elements to acquire in hydrogen exploration today? And how can, for example, advances in machine learning or data processing help democratize across to this critical information?
Thank you very much for this question. So the first problem when we started exploring natural hydrogen was the absence of data, like geophysical data or any kind of data. The places where we got a lot of data was in Mali, where there was like more than 25 wells with all logs and cores and etc. So I think something that can help here, and what we have been trying to do during my research with Alain, or during PhD, was to look at the logs that can indicate hydrogen instead of having a gas logging clearly showing hydrogen. So by combining some tools like Neutron that are very common and has been looking and occur in a lot of oil and gas field, to see how we can identify and take off some signatures from these petrophysical logs to catch the presence of free gas, not only natural hydrogen. So that are the kind of methods that need to be, we began it with the data from Mali, but it need to be further developed so that all the oil and gas companies that has a lot of logs data can apply this kind of methods to distinguish or identify or to make a first assessment to see that if the neutron anomalies or another tool can show them the presence of natural hydrogen. So these are the solutions that can help on making it more easier. Otherwise, we just have to drill to find it. Yeah.
That's my next question, maybe to Humberto. Which level of geophysical confidence do you believe is needed to justify drilling for natural hydrogen? Pretty tricky one.
Another tricky one. Thank you very much.
It's open to everybody.
It depends. Again, it depends. It's quite difficult to be conservative in this moment of the natural hydrogen because we are in a frontier moment. So you need to take the risks. It's impossible to run away from this. You need to take the risks. But the good thing is that we do have many tools to apply. For instance, when we are exploring sedimentary basins for natural hydrogen, it's quite common to have legacy data. So if we have this information, we have the same information the oil and gas industry has to solve the problems. So you take the information, you interpret the seismic sections, you combine this interpretation with the potential geophysical data, and then you decide where to drill. But my only point on this, besides taking the risks, is since we are in the very beginning of the exploration, I do recommend to try to combine all the elements, as most elements as possible in the same prospect. So if you find a prospect that can combine different types of source rocks, different types of efficient migration pathways, reservoirs, and a very good seal, drill there. But take the risks.
The risks.
Yeah.
Yes, and just in addition, one thing will be to go deeper on all these valuable data that are existing in Mali and to try to leverage the knowledge from this and try to apply it to similar location over the world to see if we can get something from this. This can be the low-cost way to do it and to serve natural hydrogen. And I think these are things that, for example, Association of Geology Hydrogen, which is in US, is looking for and trying to do to make the hydrogen data platform where data that has been occurred can be analyzed and can be leveraged to give more information, more method that can help on identifying and understanding natural hydrogen and reducing the exploration cost for the companies. Yeah.
Okay.
Maybe can add that the good news for this question of drilling is that for the moment we are looking for what we'd call easy hydrogen because it was not explored before. So all the exploration is onshore, and the depth of the wells which have been drilled so far is relatively shallow. This, as a clear consequence, is not too expensive compared to where we are now for oil and gas exploration, where the wells are very deep and very often extremely expensive. The price you need to spend for hydrogen well is generally modest when you compare to oil and gas industry. So of course the risk is still high because, as we know, we are at the beginning of the knowledge and there are more questions than answers for this exploration. But the risk is also limited because of the relatively low price of the wells which have been planned or drilled already.
Okay. And speaking of risks, Romulo, regarding stimulated hydrogen, do you think the risks are mitigated? As in principle, we just need the rock is there, and all I have to do is stimulate it. And also, could minerals be extracted in this process, for example? What are your thoughts about this?
Yeah, that's a nice question, really. Again, we need to make the balance in between the energy, the cost, and etc. What I've been trying to do is trying to do both, hydrogen generation plus something else, in this case, sequestration of carbon. Then if we combine both, then I think that could be a nice thing to keep going, because, for example, currently, what I've been observing is that, okay, you can produce hydrogen. It's quite easy to produce because you have this kind of a reaction that's going to produce. However, we have this competition because together with the hydrogen, we are producing methane. So, okay, back to the problem. Methane could be a problem, could be used, could be doing, can I do something with this methane that's being produced, or should I avoid this production of methane? So how to get the well balance in between one process that was the carbon capture plus hydrogen production. And sometimes when you produce lots of hydrogen, then you produce methane as well. So you have to combine things in order to understand if it's going to be good or bad. In something that keeps on my mind is that when we start doing this, we thought about, okay, let's go to the field of the old fields of oil companies, for example, that they don't use anymore, and trying to do this on there. Okay, that's very cost. I reckon that's very expensive and things, and you have to change everything in terms of the ideas, in terms of engineering. And currently, maybe thinking about mining, mineralization, sort of, doing mineralization of the rock itself. So maybe it's better going to the mining that's using the rock, the basalt itself, or any kind of rocks, and trying to work with the thing that they don't want to work with, the thing that was left over. So trying to mineralize these leftovers of the mining companies and trying to produce hydrogen from there. I don't know. You need to understand this better to do the best fit of the cost and try to understand. But okay, you need to do this. I think that's very interesting. We don't have the risk to produce the hydrogen. We just need to understand if it's in terms of the money itself, in terms of the cost. Also, what kind of water that we are going to use this, because water cannot be the cost of the water cannot increase because we are producing hydrogen from there. So we need to think a lot on this.
Yeah.
But then you need to have the results, and you have to control the results first. So then it's the second part of
Another step.
game, I reckon.
Yeah, okay.
Maybe speaking about economics of hydrogen, there's something that we didn't discuss yet today, not very much. It's the possible presence of helium. And three of us, we were last week in a 8-night meeting in Paris. And my feeling, I don't know if you had the same feeling, that hydrogen exploration is associated with a very high risk because we don't know the flow of generation, etc. And because the price selling of hydrogen is relatively low, it's about $1 a kilogram. If you find associated helium, the price of helium is more or less 100 times the price of hydrogen, $100 a kilogram. And it seems that for us geologists, what is considered as a hydrogen accumulation with helium as a byproduct may appear for the industry like a helium prospect with hydrogen as a byproduct. If you have, for example, a gas with 60% H2 and 2% helium, which is not rare, it's something which occurs including in Brazil. For us, it's a hydrogen field with some helium. But in terms of money, you will get more money selling the helium than the hydrogen. And even if the flow rate is relatively small, helium will be quite valuable. So in terms of business model now, maybe we can always think about the associated helium. We will change the business model of hydrogen exploration. I don't know if you agree with that.
Yeah, I think that this is a very important point we have been able to see on feed when we are doing exploration. Most of the time we found hydrogen associated with helium. So as you say, helium value is 10 times or more than, 100 times than the hydrogen. So it means that this can be a new way to de-risk natural hydrogen exploration. Because if we found it associated with helium, certainly for the financial people and investors, it will be more interesting to look at this. But there are some questions about the separation of these two gases, so that are also some of the points. But I think the technologies are mature in separating natural hydrogen and helium. And
maybe I forgot a point about that, mainly in Brazil. If you look for a helium prospect, you have already the legislation which is ready. If you look for hydrogen prospect in Brazil, it's still not ready. So that's also a tricky way to be able to push hydrogen exploration behind helium exploration, which is already organized with a legal status in some countries like Brazil.
Nice.
Yep, I do agree. Yeah, I do agree. The business concept benefits a lot from having helium in the system, and also the geology. We know much more about the helium system than the natural hydrogen system. So if we find this accumulations, this mixture, we can track the helium.
Yeah.
In a more, I don't know, it reduces the risks just in the starting point of the exploration. So I do agree with that.
Nice.
And to finish, it changes a little bit the scenario, because if you are looking for helium, we are looking for specific geological settings. Most of them are in the interior of the continent, especially within cratons. So it changes also the concept in terms of play.
Okay. Well, we're almost approaching the end of our panel, but I'd like to know from you guys what comes next. That's one of the main questions. So looking ahead for the next few years, what do you envision as the main drivers of hydrogen exploratory success, whether in regulatory frameworks, new geophysical technologies, or collaborative models between industry, service companies, and academia? Who wants to start?
Well, I always claim that in the coming years, the main point for success will be that one company in the world will say, I'm selling natural hydrogen and I can make money with that. That's years that we are working on this field, and the community is big and a lot of companies are drilling and presenting results. Today, no company except Hydroma in Mali, but it was extremely marginal and now it stopped because of political reasons. No company has been producing really hydrogen. I think it's very important for the investors to be reassured that it's not just an idea of crazy researchers, but something which is a real business. It's important for us scientists because thanks to a future production, we'll understand much better the hydrogen systems. We spoke about the Malian case, which is the most advanced case study today. Thanks to this production, we have seen this refill of hydrogen in the accumulations. just with our models or experiments or thinkings, we are not able to prove that. So the industrial production of hydrogen will secure the investments and will help the understanding of hydrogen. So for me, it's really the key issue in the coming years.
In my side, I think there's good. We can still believe in this, and it will arrive with all the companies that are drilling now. Maybe in the next years, we'll see very beautiful information and data that will come from them. One example is the Hytera in the US, who say that they have some flow rate now, so which is very interesting. We are still waiting for the value and the element, but it's a big word to say that they have a flow rate. So that can also change the paradigm. And to just conclude on this part, for example, the Malian case will be a good example, but the project was done for like a pilot project for the village. But sometimes in my company we used to try to make some economical calculation to see how much profit they will be able to generate it from this well that was discovered accidentally if they was selling the electricity instead of giving it for free for the village, and comparing it and making calculation based on the electricity price per kilowatt hour and from Mali in 2012 to 2025, you can see that if the purpose was to clearly make money from it in these locations, notably developing countries or Africa or Mali, it can be good, because from just an accidental well which is with reservoir at 60 meters, the capex is even less than 1 year. It's done. So yeah, but hopefully it happen in another country where it can be bigger noise and make it de-risk the natural hydrogen. So that is one of our objectives.
Okay. Humberto wanted to complement, give your vision.
There is an interesting history. Last week we had a meeting in the International Energy Agency just discussing, there is a rating, a kind of rank. You put numbers in order to orient the investors. So if it's higher ranked, it means that it's good, go there. If it's not good, don't take care.
Was it TRL scale, maybe?
TRL, yeah, this one. So we were trying to figure out which are the elements that could help us to define the TRL for the natural hydrogen. And we take small steps, we took small steps. Firstly, is there natural hydrogen? Yeah, okay, so 1 point there. Is it possible to, there are, I don't know, it was drilled and found, other point, and things like this. But the critical point we reached was the well flow. Mm-hmm. The well flow is the critical point to define if we had someone producing and earning money from the natural hydrogen or not. So I think this is what we need to know in the near future. We need to know the well flow. We need to know the reservoir behavior. It doesn't matter if we are talking about some accumulation down in the subsurface, or we are talking about someone that is replenished through time. We need the well flow. We need to know how much hydrogen will be produced there. This is the major risk of hydrogen that can be reduced, as it was mentioned here, if you have helium there. And to solve this problem, I think that the formula does exist. We are talking about the beginning of everything. We need collaboration. We need collaboration between all the segments, industry, academia, and also between the companies. We need to change the mind for the subject. We need to change the ideas on that. We need regulations. Everything that is started, I take here the example from the unconventional industry. many things were needed: the technology, the concept, the regulations, the environmental elements. So we need to combine everything, and we need to collaborate.
Yeah, that's true. Thank you. Microphone. I still have one quick question for you all. So almost ending.
I'll try
Go
to
ahead.
be quick. So what's the future? I reckon that the future is very long. I've heard the future is very extended, I reckon, because you are really in the beginning of this. You know, theoretically, you know everything about the hydrogen production or whatever, but you need to understand if you can find it and what's the perspective of to find it. So I agree with everybody. We need to have the technology to go further and try to find something that indicate that hydrogen was produced there. Also, I think that we need to change our mind about the system itself. I think that we need more engineering. I think that from my point of view, we need to work more with the engineering people, because maybe we need something from the engineering to help us in terms of geology area.
Nice.
In order to find it and to, in my case, to promote the production of this and trying to drop the cost of this. And the third thing is that you need to decide, okay, you are going to have hydrogen, you are going to decide, okay, independent of the cost, hydrogen is going to be a good metrics in terms of energy. So you need to decide this frankly. And then maybe based on this, you make the regulation for hydrogen in any kind of aspect, because it's very delayed. So you need to decide this. It's a kind of decision, I reckon.
Okay. So guys, let me just ask a final question, because we are almost running out of time, but we can start with Omar. 1 minute. Can you, actually 2 questions. Is hydrogen hype or hope? And what would you say to the young explorationists who are starting this journey with geologic hydrogen? In 1 minute.
Wow. I trust that I will start with the young generation. I think that natural hydrogen industry will go for a long time. So it's a very good time to integrate it and to start being part of this. And as I was saying, there is an association for geological hydrogen, which is very engaged in this kind of helping hydrogen to be in tomorrow energy resources, and also the academy and also research. And upon that, yeah, hydrogen is here already. You know, it's only depending on what we want to do with it. And what I like to say is, I do believe that for developing countries and African countries, hydrogen is the solution, because if you look at the project as a pilot project, more than a gigant field where you produce it, is something that can happen where you can decentralize, and for communities that didn't have access to energy to try to find hydrogen in these places, use it by generator and to produce electricity for this kind of people. So I believe that this model will work. It's working right now. So, but for the industrial part and industrial volumes and etc., yeah, that's what can maybe take time, but hydrogen is here.
Okay. Well, who's the next? Final takeaway, Humberto? Message for young explorationists?
Wow. You have a big responsibility with the word. So I think that the first thing is starting to look a little bit more on this problem we are facing now in the world regarding the global warming. So think about new solutions, think about how your knowledge can help us to find the solutions. And when you look for the natural hydrogen, think about the principles, think about the basal concepts. We have in the science and also in the industry, we developed many different things. Every time we found a problem, we developed a way to solve this problem. So we have the tools, we have the ways. I think that you just need to look for the problem, take into account the context, and try to use the principles, the basic concepts to solve the new problems. So I think that you need to be engaged thinking about this point.
Thank you, Alain.
Maybe 2 points. We have to deal with our energy transition, and for the moment, it's not ready. We don't know how to move to a future with our needs in energy that we have already, plus, as you know, the IA and the data centers, which will increase the consumption of 30%. We don't have the real tools now to solve this problem in the future. I'm not saying natural hydrogen will save the world, but it's part of the possible solutions for youngsters. I think it's very important. The second point, it's new. It's a new research for anyone who has the will to be adventurous in research and science. I think it's a wonderful experience to begin to work with hydrogen. I'm an old researcher. I've never been so excited by research thanks to this field of new hydrogen exploration, etc. So it's something extremely exciting for a youngster wanting to do some exciting research and something which may be extremely important, paramount for the future of our energy world.
Thank you, Alain. Romulo?
I will take this last sentence. I think that's very interesting, very exciting for all of the young people. I think that's the opportunity to start with something that's starting as well. So it's very exciting to the young people to jump in this subject because it's the beginning. And just another thing, that's working together, because you need more expertise from other areas. So I think that's very important to congregate, to work together with other areas and understand a little bit better about some things in the border of our knowledge. It's going to work.
Okay. Well, I agree with you all. It's a very exciting period for hydrogen. Hopefully, Brazil will progress. It will get there eventually, hopefully soon. And it was my pleasure to have you guys here. I know all of you from Alain, for example, for decades now. I'm not sure, but and I know all you guys, Romo more recently. A pleasure to work with you in Petrobras. And I would like to thank the organizing committee, Suzane, Paulo Johan, Alexandre Augusto, who invited me to be coordinating this panel. It was a real pleasure. And I would like to thank you all to be here today. And applause for our distinguished panelists. And the panel is officially closed. Thank you so much. Vamos, vamos.
efficiency and reducing uncertainty. In many onshore basins, the main challenge is no longer only finding hydrocarbons, but increasing the quality, density, and usability of existing data. Technologies such as artificial intelligence, advanced imaging, and the reprocessing of legacy data are becoming powerful tools for better subsurface understanding and risk reduction. Another major dimension of today's panel is the reopening of basins such as Paraná and Amazonas, where companies like Eneva are implementing integrated models that combine exploration, power generation, and carbon management. These new onshore campaigns raise important questions. How can this new data contribute to national energy planning? How do companies overcome the logistical challenges of remote areas? And what development models ensure a resilient and economically viable gas supply chain? Finally, large operators such as Petrobras continue to play an essential role as the company modernizes its strategies, partnerships, and technologies. We will explore how knowledge sharing, data cooperation, and open innovation can help attract new investment and accelerate the pace of onshore development across the country. To conclude, that's the question that I will make to all panelists. I will ask them to reflect on a central question, considering your different perspectives from operators to service companies and government. How can sustainable geophysics contribute not only to revitalize the onshore sector, but also to delivering real social and environmental benefits for the communities that host these activities? Okay, so let's start. I will call the panelists the big stars of this afternoon. The first one, ladies first, Núbia Deiró from Petro Recôncavo. Núbia, please take the first seat, Núbia. Núbia Fontes Reis Deiró, geofísica. Sometimes going to mix here Portuguese, okay? That's part of the plan for this panel. Núbia, geofísica, com mais de 13 anos de experiência em interpretação sísmica, focada em campos onshore. Formada pela UFBA, concluiu o mestrado em Ciências e Engenharia do Petróleo pela Unicamp e atualmente cursa MBA Executivo Internacional no IESE. Há 3 anos e meio integra a equipe da Petro Recôncavo, onde atua como coordenadora de geofísica. No cargo, contribui diretamente para a exploração onshore e desenvolvimento de campos maduros. Atua no setor de desenvolvimento e também presta suporte estratégico ao setor de novos negócios da companhia. I would ask you an applause to welcome Núbia. Okay, the second panelist, Mr. Márcio Félix, please. Márcio Félix Carvalho Bezerra, presidente da ABPIB, também CEO da Energy Platform, formado em Engenharia Eletrônica pela Universidade de Brasília, especialização em Engenharia de Petróleo pela Universidade Petrobras, MBA em Gestão Empresarial pela Universidade Federal do Rio de Janeiro, curso em Parcerias e Alianças Estratégicas pelo INSEAD, na França. Trajetória profissional: iniciou carreira em 81 na Flopetrol Schlumberger como engenheiro de testes de poços. De 83 a 2019, trabalhou na Petrobras, começando como engenheiro de campo, de avaliação de formação na Bacia de Campos, depois ocupando vários cargos gerenciais em exploração e produção. Atuou como secretário de Estado de Desenvolvimento Econômico do Espírito Santo entre 2010 e 2012. No âmbito federal, foi secretário de Petróleo, Gás e Biocombustíveis e também secretário executivo no Ministério de Minas e Energia entre 2016 e 2019. Em março de 2020, assumiu a liderança da Energy Platform INP com o desafio de desenvolver ecossistemas energéticos no Brasil. Foi eleito presidente da BPIB e tomou posse em maio de 2023 durante o evento Bahia em Gas Energy em Salvador. Sob sua presidência, ele destaca a importância dos produtores independentes no Brasil e a necessidade de expandir sua relevância e integração no setor. Aplausos to Márcio Félix. Welcome, Márcio. Now, Mr. Luiz Rosas. Please, Luiz. Luiz Felipe Rosas, VP of Business Development Latin America at BGP, has over 25 years' experience in the oil and gas industry, including 10 years in the exploration seismic sector. He has led major initiatives expanding geophysical service across South America, and he held senior roles at Petrobras and international service companies, driving multi-million-dollar projects in partnerships in CCUS, hydrogen, geothermal, and renewables. He holds an MBA from the University of Connecticut and degree in engineering from Simón Bolívar University. Applause to welcome Luiz Rosas. Next, Mr. Diogo Michelon. Diogo, a geologist with a degree from Unesp Rio Claro, holding a master's in basin analysis from UERJ, and an executive MBA in project management from Fundação Getúlio Vargas. With 18 years of experience in exploring Brazilian sedimentary basins, he is currently the general manager of exploration at Eneva, where he leads initiatives in seismic acquisition, processing, interpretation, prospect definition, and discovery assessment. Applauses to Diogo. Next, Mr. Aloysio Pelon, a skilled explorationist and manager with more than 40 years of experience in the oil and gas industry. He graduated in geology at University of Bahia in 1981 and took his master and doctorate degrees in sedimentary basis analysis at UERJ in 2000 and 2005, respectively. Aloysio worked at Petrobras from 82 to 21 in several international exploration projects in North America, South America, and the Middle East. Since 2022, Aloysio has been working at Enauta, later Brava. As the executive exploration manager, Aloysio coordinates both onshore and offshore exploration activities in Brazil, comprising exploration blocks and upsides in production ring fences to add value for Brava's shareholders and society. Applauses to Aloysio Pelon. And now 60. Our 60th panelist, Juliano Stica. Juliano is the General Manager of Exploration Assets at Petrobras, responsible for the southeast and east margins of Brazil, including Santos, Campos, and Espírito Santo basins, as well as onshore basins nationwide. In this role, Juliano leads the evaluation of exploratory opportunities in regional geological studies in these key areas. Applauses to Juliano, please. I'm sorry, I have some more about Juliano here. He holds a degree in geology from the Universidade Federal do Paraná in 2004 and a master's in geotectonics from the Universidade Federal Fluminense in 2013. Stica joined Petrobras in 2006 as a geologist focused on the equatorial margin. Throughout his career, he has contributed to regional studies in nearly all of Brazil's onshore and offshore sedimentary basins, specializing in geotectonics, play analysis, and prospect evaluation for bid rounds. Since 2016, he has held various management positions at Petrobras. Applause again to Mr. Stica. Okay, so let's start our work here. The format of this panel, in this format of the panel, as we negotiate here, each of the panelists, we have like maximum 5 minutes to deliver his or her main message, and after that, we go to a round of questions here for them to answer, okay? So, the first one I call here is Luis Rosas. Is that okay for you? Let's start with Luis Rosas. Actually, we didn't negotiate the order, okay? So I'm sorry for that.
Hello, hello. Can you hear me? Yes. Okay. Well, first of all, thank you so much for sharing this round table. Some of them are my friends, some of them are long-term. In 5 minutes? What is it? Okay. Can you use this? No, it's
Oh, you can use it.
but it's a hair presentation.
That's your presentation? Oh my gosh. So let's change your order. I'm sorry about that. Luis, please sit down, Luis. I have to follow the order of the how they put on the system, okay? So much better now, huh? Oh, Luis. Nubia, please start.
Okay. Thank you everyone. Thank you everyone for stay here. I'll make my presentation in Portuguese easy for me, but if anyone has some question, please ask me after the presentation in English. It will be a pleasure, okay? Yeah, ok. Eu vou falar inicialmente um pouquinho da PetroRecôncavo, hoje como coordenadora do ativo Potiguar, mas é uma empresa que ela começou com o desinvestimento da Petrobras, né? Ela tinha um contrato de risco com os ativos da Bahia, depois com o projeto Topázio ela adquiriu os campos da Potiguar, participou de alguns projetos de M&A, onde adquiriu o campo de Tartaruga, que é lá em Sergipe. Então, hoje, nossos principais ativos, elas vão estar no Potiguar, Tartaruga e na Bahia. Tá? Nossa produção hoje está, em média, 26.000,4 barris de óleo equivalente por dia. Os principais marcos desse ano para a PetroRecôncavo, a gente pode falar da aquisição de Guamaré, né, que 50% que envolve 2 UPGN junto com a Brava, e o Oil Transportation para o Porto de Pecém, lá no Ceará. Também tivemos alguns marcos iniciais, marcos importantes na área de perfuração. O que eu posso destacar é a perfuração de 3 poços profundos, onde o Biriba 19 chegou a 3.600 metros, com uma sonda que é propriedade nossa, que é a PR-14, tá? E nós furamos os nossos 2 primeiros poços horizontais, que estão em fase de teste agora, para a gente, com fé em Deus, colocar em produção. Indo agora na parte de exploração onshore. Como eu tenho 5 minutos, eu termino falando um pouquinho mais rápido, mas depois nós podemos conversar, quem tiver alguma dúvida, algum interesse. Como background, e eu quis colocar esses pontos também como desafios para nós de empresas onshore, né? Que seria, primeira coisa, o preço. As empresas prestadoras de serviço, elas terminam querendo cobrar de nós o mesmo valor que eles cobram para empresas offshore. Só que se nós compararmos a produção, um poço produzindo no offshore para um poço produzindo no onshore, é muito complicado. Eu não consigo. Às vezes, nós queremos fazer reprocessamento, nós brigamos, eu, como geofísica de formação, brigo para a gente conseguir reprocessamento lá na empresa. Quando nós recebemos os orçamentos, são algo absurdo. Então, assim, eu nunca consigo aprovação. Então, acho que um dos principais pontos e desafios nossos é conseguir preços, seja a própria parte de perfuração, tanto que muita coisa nós fazemos a verticalização, né? Nós temos sondas próprias, nós temos a parte de fraturamento, todas da PetroRecôncavo, justamente para baratear esse preço. Tá? Nós também na parte não só na revitalização de campos maduros, nós estamos na parte de blocos exploratórios. Nós temos 2 blocos hoje que estão na parte de estudos, e temos um bloco que já se tornou o campo Sabiá Laranjeiras, Então, tudo isso são esses pontos estratégicos para a gente poder fazer não só a petrorrecôncavo, mas a parte do onshore brasileiro crescer. E como é que eu vejo o crescimento, né? Como é que eu vejo essas perspectivas? Eu acredito, como técnica também, não só nessa parte gerencial, mas eu vejo que o onshore brasileiro ele tem ainda muita coisa para crescer. Existe muito óleo escondido, que eu brinco, muito óleo não drenado ainda, mas para a gente poder enxergar esse óleo residual, vamos falar assim, a gente precisa, primeiro, trabalhar os dados existentes. A maioria dos dados que nós temos hoje foram adquiridos pela antiga concessionária, que era a Petrobras, né? Esses dados reprocessados em 1900 e alguma coisa muito antigos, com a qualidade péssima. Então, nós precisamos realmente ter esse budget, esse orçamento para poder trabalhar esses dados, melhorar a qualidade desses dados. O Brasil ele representa 6%, né, da parte de produção, o onshore. Nós podemos crescer isso, ainda vemos mercados para isso, e a ANP ainda vê um crescimento de 30% na produção onshore. Com isso, se nós não quebrarmos, nós não rompermos essas barreiras existentes, a gente nunca vai conseguir. Empresas relativamente pequenas, como a Petrorrecôncavo, a Origem, a Petrovictor, essas empresas, elas encontram essas barreiras no meio do caminho. E se a gente não conseguir, a parte regulatória, para nós conseguirmos uma licença para perfurar um poço hoje, pode chegar de 1 a 2 anos, às vezes. Então, tudo isso serve como barreiras e dificultam o próprio crescimento de nós como empresas independentes. E é isso, gente. Obrigada.
Ok. So, next speaker, Márcio Félix, please. In the right order, right?
Good afternoon, ladies and gentlemen. Very happy to be here in this very distinguished audience and my friends panelists here. I'm talking on behalf of the independent companies. So we have here some of the independent companies in the panel as well, are our associates. We have some challenges. Nubia talked something about the supply chain market that it happened in the time of Petrobras onshore, that the prices, the services onshore should be very expensive in comparison with the competitiveness of the assets. But Petrobras could compensate for something by organizing the market. Okay, you have a company A, you have a Campos Basin and then Potiguar Basin, and then you can have a balance. But it's not only for supply market, but for the regulatory agents as well. We are treated, or for the environmental boards, federal or local, we are considering like Petrobras. So the same challenges, and Petrobras worked to make a role to organize the priorities, but now are many priorities in parallel. So it's more difficult to get. So we need to have a kind of paperwork that should be changed a lot, but not only the paperwork, but the mindset should be changed in order to have more competitiveness onshore. Most of the onshore now has been taken care of by independent companies. Petrobras remains in Urucu area and in one cluster in Bahia. And that's a big change. Now Petrobras is small onshore, much smaller than it was before. So we have not only the regulatory agents, ANP, but the Energy Research Office, EPE, should take care a little bit more about how to carefully plan our energy resource for the future coming from onshore. Onshore now is not only more light oil, let's say that be the dream in the past to make a discovery of light, mid crude, light crude. But now it's gas, so these gas-prone bases are becoming important, like Amazonas, Solimões, Parnaíba, Paraná, Tucano, even the central bases, so in the Midwest of Brazil. So we are in a different place. Now we consider as well carbon capture, underground gas storage, maybe geothermal, other solutions that can be working together with the same knowledge of the oil and gas. So we have the rounds of permanent offer of ANP. You have one more with more blocks. More blocks were just approved to be offered. So most of the acreage onshore for exploration is with independent companies, some very small companies, so with different ideas, with different mindsets. But we need time. Maybe we have a lot of changes in the bid rounds to have more time, to less guarantees. It's very hard for a small company to get all the not only environmental permits but the financial permits of the market. So it's something for the big ones, that big companies that they have investment grade. They can guarantee their own assets, their own operations. But the small companies need to go to the financial market. It's very expensive. It costs a lot of time as well. So it's something that needs to be changed. I believe we are in a changing time. You have now, these days, gas is important for new discoveries. Not only gas, but low sulfur heavy oil that was not very well valued in the past. But to produce asphalt or to produce lubricants and other oil byproducts, I mean, not say about the diesel, gasoline, or jet fuel or something like that. But so there is a different, of course, exploration around the production clusters is important to me, because there's no more room for new divestments, for new. So we are living an organization of the markets. The new, I like to call the new clusters, like Brava, like Petro Recôncavo, Eneva, and the others. They are the bigger ones. They are divesting some marginal fields for them. So we have a new company. So it's a new organization. Not in Brazil we're not very big onshore today, but we are spread at different bases. It's so far away in very different places, like Amazon. Working Amazon is very close, very very challenging. Or new frontiers, or where we have the agribusiness there. Just to finalize, Luis, I would like to remember that the Ministry of Mines and Energy was created in 1960. Was the final decision, one of the final signatures of the former President Juscelino Kubitschek. Was the last day of his. In the Ministry of Mines and Energy came from Ministry of Agriculture. So there's a relation. We became far away from the Brazilian Geological Survey. So I guess the key words now is integration to explore in a very competitive way. There are a lot of thousands of wells have been drilled, a lot of data that are in papers, are written reports, like I used to do in my past as a formation evaluation engineer. The reports are written, so we need to digitalizes, but we need to put some intelligence to integrate. Big supercomputers are available for anyone, but we need to make something to integrate this in this new time of carbon capture, geothermal, and others that work together with oil and gas industry. Thank you for your attention, and they'll be available for other questions.
Thank you very much. Thank you. Next speaker. Now it's your turn, Luis. Okay, the slides for Luis Rosas, please. Okay. Is it empty? Okay. Now we have it.
Thank you so much. Okay, I promise you I'm going to be very brief and straightforward. But today, what I would like to share with you is it's our vision as a geophysical service company on the future of the onshore exploration in Brazil. So let's start. Which is, nowadays, what we have in mind is there are three key aspects when we talk about the future of the onshore exploration in Brazil. First of all, knowledge. Second of all, efficiency. And finally, intelligence. This is basically just to say that with quality data, good information, you're going to make better decisions. This is basically what these three key words are trying to say when we think about the future of onshore exploration in Brazil. However, what is our reality in Brazil? The majority of the onshore basins are unexplored, and also the data that we have is outdated. This is the big issue. Simple. I'm talking about onshore, right? But also the reality is, from the strategic point of view, this sector is still important. We cannot say, as some people say in the past, that when we talk about offshore, we talk about the Champions League versus Campeonato Nordestino, or whatever it is, a minor league in baseball, if we talk about baseball or whatever. It's as important as any other sector. Why? Because first of all, the cycle from discovery to production is faster, it's shorter than offshore. Second of all, it's more capital efficient in terms of exploration methods. Plus, lower carbon intensity practices, which is true. And also, we can support the regional development in country level, state level, whatever it is. And finally, enhance energy security, which is a very important issue nowadays around the world. So, this is the reason why all of us are here today talking about this. So what we need, from our perspective, is, as we thought in the past, talking about offshore, of course, any business model, any approach, like multi-client that we did in the past with the offshore, but we need to go beyond that. Beyond that, meeting the needs that we have nowadays in the offshore sector. So what we call the key levers is collaboration. Collaboration among all stakeholders. Here in this Congress, we have a lot of stakeholders. We are creating a different business environment, more than technically speaking. It's not only about technical, it's about environmental, it's about business, it's about students, it's everything. All of these people, everybody have to be involved. So, but collaboration on what? On cost sharing, risk sharing, permitting, and how to deal with other stakeholders like communities, like regulators, like anyone who cares about the project or the development or the exploration on the onshore sector. This is what we mean with collaboration. And one key word that is being repeated in the last 3 days, communication. You don't collaborate if you don't communicate with each other. This is the key thing. Second of all, technology. Yeah, we're talking about AI, we're talking about G&G methods, but what is the right approach to use all of these things which are available in the market? In our opinion, it has to be not the step-by-step approach, like seismic processing interpretation. No. You have to be well integrated. There is no magic, there is no only one formula in the exploration sector. So it means we need to integrate everything that we have available for that specific need, for that specific goal. This is the way to change the mindset that we've been developing, conducting in the last maybe 20 years. Finally, share the vision. I already talked about Champion League, Campeonato do Destino. Yes. But the onshore, it has to be treated as a new opportunity to rediscover what we have, not only oil and gas, but we have new energy models, CCUS, we have geothermal, we have hydrogen, we have different sources of energy nowadays that we would like to develop. So as a final message, just to summarize it, guys, the rocks are ready, the technology is proven, but it's time to move on. It's time to make new business model, different ways to work, all of us, and have a collective will. So, thank you so much. And
Thank you, Luis, for so strong recommendations and remarks. Okay, next speaker, Diogo Michelon. Diogo, please.
Good afternoon, everyone. Thank you, SBGF, to the opportunity. Thanks, the colleagues here, to you join us this sunny holiday in Rio. So I will talk briefly about the onshore seismic projects that Eneva has been done in the few years, and also the ones that on progress. Actually, as you can see in the right side of the picture, the Parnaíba Basin is the basin that we are working the last 15 years. Those are all the projects that we performed so far. So a lot of them, almost 40,000 kilometers of 2D seismic. There are two 3Ds, are not so big, but there are 3Ds also. And you can see that we are performing in terms of acreage and amount of seismic, a lot of acquisitions as a private company. And this is really important to the discussions that we're going to have here today, is the base of the interpretation and the base of the new discoveries that can be done in basins in frontier basins like those ones. The left side is the Paraná Basin. Paraná Basin, where we have a partnership with Brava, is a campaign that is a very frontier basin, greenfield. The part of the basin that we are working on, the west side of the basin, actually this basin is more than 1 million of square kilometers, is really big. And this part of the basin is, let's say, understood so far because there is not so many wells. We are very confident with the opportunity and the potential of this part of the basin. Is a project with about 4,000 kilometers of 2D lines, divided in 2 states, Goiás and Mato Grosso do Sul, and is really challenged due to the agribusiness that is installed on this part of the country, and we have a lot of issues and discussions to be done on this thinking about the challenges related to acquisition in a region in Brazil like this one. And in the center is the Amazon Basin, where we have 3 blocks, 2 accumulations and another one to be developed. Is Azulão Field, Tambaqui Field, and also Japim. We are running, is on progress, this project actually. We are on 90% of the 3D acquisition, is almost ready. Inside this 3D acquisition, there is a DAS VSP acquired together to have an enhancement of the data. Will help us a lot to have more information about the complexity of the structural framework related to this field. We use 3 wells with optical fibers to have this data, and is a 3D with about 400 square kilometers, 400 square kilometers of data that we have. We started with cables, with a system with cables, and we moved it during the project to the nodal system that has been a solution to the production due to all the challenges that we have been during the project, and this is running fast, and we're gonna finish before the rain season. And also there is a 2D around it that will give us more information and infill lines to the prospects that we're going to support the drilling campaign of the new and wildcat wells. The next is a movie, very fast movie with some highlights and some images of the project. I think that images talks more than words, and considering that is a project that came over many years without any seismic acquisition in this kind of environment is really interesting. So.
A Eneva tem a missão de liderar soluções energéticas para uma transição segura e responsável. E estabeleceu um objetivo ousado: estar entre as 5 maiores empresas de energia do Brasil até 2030. Protagonista na exploração onshore há mais de 15 anos, em 2025 rompeu um hiato de 12 anos sem aquisição sísmica terrestre no Amazonas.
Então, entre muitos desafios que um projeto como esse oferece, nós temos, para milhares de pessoas que estão envolvidas e a quantidade de tempo que um projeto como esse abrange, nós temos uma equipe muito competente em campo, que são fiscais com vasta experiência, que é um time da Eneva na qual já participou de outros projetos, de outras campanhas e também já tem experiência com projetos como esse em selva. Portanto, eu tenho plena convicção que o projeto será um sucesso devido à capacidade das pessoas que estão envolvidas nele.
Em parceria com a EAD BGP, encarou um desafio inédito: realizar uma campanha sísmica em plena floresta amazônica. Foram mais de 1.400 profissionais, cerca de 500 quilômetros de sísmica 2D e 400 quilômetros quadrados de sísmica 3D, seguindo rigorosamente o ciclo das chuvas. Com o know-how de campanhas no Parnaíba e no Paraná, a Eneva transformou um projeto considerado quase impossível em realidade, mantendo segurança, excelência técnica e qualidade dos dados. A operação movimentou a economia local, utilizou helicópteros, barcos e veículos e manteve o compromisso com as comunidades e o meio ambiente.
Programa sísmico 2D, 3D Tambaqui acontecendo a todo vapor, e desejo sorte aí pra gente, que a gente consiga no final entregar um dado com muita qualidade, com segurança, e que a Eneva consiga realmente achar muito gás aqui no estado do Amazonas e continuar ajudando o nosso país aí no que se refere à parte energética.
Inovando com tecnologias cabeadas e nodais, elevou o padrão da sísmica terrestre no Brasil. Eneva, energia responsável, inovação e compromisso com o futuro.
Thank you.
Thank you very much, Diogo. That's really amazing. When we think about exploring the Amazon jungle, that's the kind of time when they mix the technology and emotion. Because I started 45 years ago in the Amazon, and I saw the Amazon jungle there. Okay, that's really hard to work in that place, man. Next one. Aloysio Pelon, please, your message.
Thank you, Braga. Well, hi everyone, good afternoon, audience, my dear colleagues. I'd like to thank SBGF and Braga for this invitation. I would like to show to you what is a brand new independent oil field company, Brava. Yes, Brava is a company created in August 2024 after the merger between 3R and Alta. So it's a very peculiar one because we have both onshore and offshore oil and gas assets in Brazil with over 1,100 employees, contractors and consultants. We are a top-tier Brazilian independent LNG producer. Last quarter, we reached 92,000 barrels of oil equivalent per day. It's a very nice production for a junior company. Most of them coming from the offshore in 7 fields and 38 fields in the offshore. It's still a huge operation onshore. So most of the independents, the onshore exploration strategy is reserves replacement. But for Brava, not only doing workovers or drilling development wells, but it includes also infrastructure-led exploration. So we are currently reviewing a huge database that come from mostly from Potiguar Basin, and performing, as you see next, a lot of exploration works in order to bring some drillable prospects to the company and compete with development or producing capex. So our onshore portfolio comprises 13 exploration blocks, 9 as operator in the Potiguar Basin, and 4 as partner with Eneva operating in the Paraná Basin. Besides that, we have 38 production ring fences in Potiguar and Recôncavo, where we are sure to remap, do a lot of geophysical work, reprocessing, and we are sure that we can unlock additional reserves to our company from those ring fences. regarding our current onshore activities. As I said, we focus on the Potiguar Basin. We have 9 operated exploration blocks and 25 production ring fences, most of them covered by 3G seismic. We have already started a huge campaign of seismic reprocessing, started with BGP, my dear friend who is here. And just as a curiosity, Brava has the largest well database among companies in Brazil, not only in Potiguar, but both onshore and offshore. 9,800 wells are in our portfolio responsibility. So for you to understand how big is the efforts that we as an exploration team, 12 people, by the way, we have to do in order to really digest all these data sets and bring new solutions and new projects to the company. The only way to do that is working together with consultants and contractors. There's no other to do it. We have been working, as you can see, back to basics, regional gravity magnetic review with the Rio Grande do Norte University. We are performing a lot of regional 2D seismic reprocessing and 3D PSTM, PSDM reprocessing with BGP, together with our consultants. We have already collected oil samples from our 20 samples from our oil fields in Potiguar Basin, and PPS just is finishing a geochemical analysis encompassing these samples and some other samples that they have in the basin. So this will be together with the regional transects, the basin 4 basin modeling study that we will conduct next year. And also with our consultants, we are reviewing sequence stratigraphy and structural geology for the basin with new concepts, and certainly it will add a lot of value in our mapping. And also Paraná Basin, we have placed in our portfolio to high-risk frontier basin onshore. It's always, you have to leave some part of your budget for higher risk projects. That's the way the company thinks. So we hope that after the huge 2G campaign that we operated by Eneva, that we did BGP, we finished it 2 months ago, we can bring some drillable prospects and do a lot of investments in this basin as well. So what are our challenges and opportunities? So in Potiguar, reevaluate the mature basin is something bigger than one exploration manager can expect with such a small group, but we are using state-of-the-art G&G technology for helping us doing that. It's not only a matter of data, but it's a matter of human resources as well. As I said, we work together with consultants and contractors in order to provide the best data we can do for further analysis. So we are going to, besides additional 2D seismic reprocessing and stratigraphic structural interpretation, we are going to perform basin modeling, play review and prioritization. You can imagine how difficult can be this prioritization of projects, and how to generate lower risk exploration prospects and proceed with well drilling campaigns, competing with CapEx for development and producing independent companies. So we really have to bring not only geologically feasible, but economically feasible prospects in order to compete for CapEx in the company. And hoping that in Paraná Basin, together with operator Eneva, we can do prospects maturation this year, play analysis, and start a well drilling campaign by 2027. We are finally, so we can see how how we are dealing with seismic. We've got so many new data, reprocessed data with a lot of potential for new pools, deeper pools. We've got some 2D, new 2D regional lines. These yellow dots are our collection of new samples, analysis with the state-of-the-art geochemical analysis. And this will help us integrating all these huge G&G data to bring new drillable prospects and increase the reserves of the company without just investing in development wells. So that was my message. Thank you. Thank you very much.
Okay, our last speaker, Juliano Stica, please, from Petrobras.
Thank you very much, Braga. It's a pleasure for me here to be here with my colleagues, and especially for representing Petrobras, a company with a huge legacy when we talk about the onshore exploration. So my talk here today, and they bring me the presentation, is Juliano Stica, the name, please. I would like to try to explain how can we fit our onshore exploration in the E&P strategy for Petrobras. Of course, we are a company with the majority of our investments into the deep water, but we have space to do exploration. Okay, now we have it. So let's start with our business plan. We have in the exploration production segment in our business plan, we have the four main topics, four main goals. That the first one is to maximize our value, the portfolio value. This is very important for us. I will explain this more, especially when I talk about the Bahia and Urucu field. The main topic for exploration in general is the replace oil and gas reserves. And one very important thing that Petrobras put very clear in our business plan, that we need to explore new frontiers. This is very important because our current portfolio is not enough when you look for the long terms, for the future. Of course, we need to increase our supply of natural gas from our production and promote the decarbonization of our operation. But relate to specific to exploration and in the onshore, I will focus in these two first ones. So let's see, let's start with why we are saying that we need to maximize and explore again. Here we have our production curve, the forecast for next 25 years. We can see here a strong potential, a huge ramp up for next years. But naturally, we have a normal decline for the future. And this is our main challenge. We need to replace, we need at least to maintain our level of production, the current production, to the future. And we will do this in three ways. The first one, of course, are the investments that we are doing in our fields. Of course, we need to increase our recovery factor of our production. Then we have our current exploratory portfolio that I will explain in the next slide. We are investing a lot to find new discoveries, new opportunities. But as I said in the first slide, this is not enough. We need to invest, and we are investing to diversify our portfolio, entering new areas, open new frontiers. And relate to our portfolio, as I said, we are the majority of these capex, these investments are related to deep water. We are invest a lot to get access to the remaining potential of the pre-salt. Now we are open new frontiers here in Brazil, in Equatorial Margin, in Pelotas, and we come back to abroad. We are diversifying our portfolio to decrease the risk of our portfolio. But as I said, too, we still have space for the onshore. We have our remaining portfolio in Solimões and a cluster in Recôncavo Basin. We still have our portfolio in Bolivia and Argentina, and I will explain this now. In the short term, when you look for today, our strategy in exploration is to explore the maximum of our ring fences, to explore the near field, and we are already approving in our business plan investments to resumption our onshore drilling. After a long period without any new well, we already approved 100 wells only in Bahia. This, of course, not all of these will be exploratory, but the majority will be the intervention and for increase the production of the fields. But we still have potential nearby our fields, and we will already start to drill in Bahia in this year, and we are already prepared and approved to drill in Urucu field in this next year. As well, we already approved the resumption of Bolivia. We will drill in San Telmo block in 2026. And at this moment, in Argentina, in Rio Neuquén block, we are testing the unconventional, the oil, in the Vaca Muerta. We have a huge potential in this block and can put it in production at the same time we are testing. So this is our main goal for the onshore. We are, our goal is to the sustainability of our units, our portfolios. So this is why I said that we need to maximize the value of the portfolio as in our business plan. But we are looking for the future too. We are prepared. We are investing a lot in reprocessing our data. Of course, we start with this exploration in the ring fences, but we will still reprocessing some regional data. This will support us not only about the prospective evaluation, but for try to find new trends, new plays. We need to think out of the box. We have a strong demand of gas in onshore, so this is one of our targets. So this is why we are now investing in regional studies. Another thing, as I said, we still invest in Bolivia and Argentina. We think this is important not only to maximize the value of our companies abroad, but because we think that is the integration in South America is totally true. We will see the impact of, for example, Vaca Muerta in next years here in Brazil. So we need to be prepared for this. And we strongly believe in the power and the potential of to diversify in onshore. We already start studies in geothermal, studies in natural hydrogen, and of course a lot of studies in hubs of CCS that involve not only Petrobras but the entire industry. So we are invest a lot in this. So this was my message. I would like to say I wouldn't like to pretend to you that Petrobras doing a complete change to come back to onshore. Of course, the deep water is our main target. We need to find and explore new frontiers, but we still have space. We have this short term to exploring the maximum value of our portfolio. So was this. Thank you very much, and I will be here to answer.
Okay, thank you very much to all panelists. We are about 15 or maybe a bit more late, so I believe we have time only for one round of questions, okay? But feel free to use the time, no more than 2 minutes. You can expand the way you wish. You don't need to be exactly attached to my question, okay? Because of time is short, so I leave you free to send the message with the content that you think it's the most important. Okay, let's start here. Just a moment, please. Deixa eu começar com Núbia aqui. Núbia. I'm sorry. I'll start with Márcio. Márcio, let's go to this question here. How can collaboration among small producers, service companies, and academia enhance competitiveness and innovation in the onshore segment?
This is one of our goals in our association, BGP, Brazilian Association for Petroleum Independent Gas Producers. One of our committees is connected to innovation and relation with the academy. As I mentioned in my short presentation, integration in a very broad view is a kind of innovation, because we have a lot of data, thousands of wells that have been drilled, even if it's outdated data, but the outdated data has not been processed or reprocessed as well. Of course, new data is welcome. You need to put together the Brazilian Geological Survey. I think we miss it. This is one of our challenges in Brazil, to reintegrate in one piece all the efforts. I see the efforts from the universe to process data, to acquire new data. So this has not been integrated for different mindsets. Petrobras was happy to hear the Stica's presentation about some of the Petrobras ideas for onshore. But Petrobras has a lot of data, and of course it's company data, but it's something related to the country. So I guess something for the future, maybe Petrobras not divest more assets because they don't have more assets onshore, so many assets onshore, but in a certain way to have access for all this data. This is something that would be a big change for Brazil if Petrobras is not going to work anymore. So this, of course, this is not easy to say, but is to do, but it's something that you should pursue. So, and my final question is, of course, unconventional onshore, tight sands and shale is something that has some potential and must be tested. And then December 11, pay attention, there will be a public hearing in the Superior Court of Justice in Brazil, STJ, in Brasilia. That will be a discussion about allowing or not. Of course, at December 11 won't be the deadline for that, but it will be very important. So all the association, we are going to be there. People who are pro, we are against this idea, will be there, and there will be a big discussion. So it's been important for onshore in Brazil.
Okay, Márcio, thank you very much for your view. Okay, let's go from Núbia. Núbia, na sua visão, quais políticas ou incentivos poderiam fortalecer ainda mais o papel das operadoras independentes na retomada do onshore brasileiro?
Se eu for falar da parte regulatória, eu poderia até fazer uma comparação com a perfuração com os poços nos Estados Unidos, Hoje, nos Estados Unidos, as empresas lá elas conseguem perfurar poços em 3 meses, né? Muito rápido. Aqui no Brasil, como eu comentei na minha apresentação, às vezes de 1 ano a 2 anos para a gente conseguir um licenciamento. Existem vários plays não convencionais que hoje a lei brasileira ela não permite que as operadoras, ou offshore, sobre as duas, elas explorem. Então, existem várias regulamentações. Eu estava conversando com alguns colegas que têm problemas com o INCRA, com vários outros órgãos, para conseguir a liberação de um poço. Então, hoje, o regulatório, eu acho que a própria parte da lei nacional, da lei brasileira, ela nos impede de avançar, de adquirir, de fazer testes mais rápidos. Por exemplo, a perfuração de um poço horizontal. Hoje é perfurado um poço e vários braços utilizando uma única cabeça. Ainda não existe uma regulação para isso. Então, você tem que... Hoje, a Agência Nacional ela pede para uma licença para cada braço, que eu vou usar uma única cabeça para perfurar o poço. Então, tem várias questões que podem facilitar muito, que pode acelerar esse processo exploratório de desenvolvimento nas empresas onshore, barateando e deixando mais rápido. Então, com isso, e esse compartilhamento de dados, seja a Petrorecôncavo com a Brava, com a Enel, enfim, esse compartilhamento de experiências faz todo esse processo crescer e todo mundo cresce junto, né?
Okay, obrigado, Núbia. Esse é um problema na regulação, nunca vai no mesmo ritmo da necessidade de você aumentar suas reservas, hein, ao final da história. A pergunta para... Vamos a... Luiz. Luiz, what role do AI and modern imaging technologies play in reducing exploration risk and improving subsurface understanding in mature bases?
I'm looking for the answer here. Seriously.
No problem.
You know why? Because I think everybody knows what's the AI role. If you go to ChatGPT, you got the answer easily, but this is as any tool that we have available in the market. The point is how we're going to use it, how we're going to integrate it with other tools, other methodologies, and that will depend on how we're going to face up the challenges, how we're going to develop our business model, and because at the end of the day, this information, this data is the essential input to make a strategic decision. It's part of the process. So, I mean, I could give you 100 as examples. There are many applications that nowadays we have on the field. For instance, the acquisition in China, we are using AI just to identify our employees in the field, or we're using AI just to double check if our people are using all the right equipment, or if we have any animal interfering with the project area, and so on. This is just only from the operations point of view. And of course, we have in our audience a lot of people working in processing, but again, it's how we're going to use it. This is the question, you know. And finally, for that, I mean, with that in mind, we need to train our people to do that. It's also the human factor is another key point that you have to be considered, and at the time of, again, asking ourselves, okay, what is the role and how we're going to use it. Yes.
Thank you, Luis. Something that I like to hear, Luis, every time we talk about AI, that's brings first always human intelligence as the main subject before talking about AI. Thank you. All right, let's go to Diogo, please. Let's see. How can data from these new onshore exploration campaigns help shape national energy planning while addressing the logistical challenges seen in the Paraná and the Amazonas Basin, and what monetization models does Eneva envision to build a resilient gas supply chain in these new regions?
Okay. So the data, as you saw, a lot of data, the data campaigns are crucial to reduce the risk. So subsurface data is really a base of the interpretation. And the main reason is to try to find new reserves. Of course, we need to have decentralized reserves in order to have on this model that we are working on, to have the thermal backup. So it's important, as Brazil has a model that is based on the rain cycle. Thermal backup is really important to supply the stability of the energy supply in Brazil. And also is important because gas as a fuel of the model, of the reservoir-to-wire model that Eneva has, is the transition fuel to have this important decarbonization effort that has been done in worldwide. So to monetize the reserves, of course, that there are different models. Eneva has working on the reservoir-to-wire to have a thermal power plant supplying energy on the wellhead of the discoveries, but also there are LNG models that can be done. Also in Paraná Basin, there is a gas pipeline that we can use depending on the size of the discovery, using the grid market, the on-grid market. In Brazil, we are very limited in terms of gas pipelines in Brazil, but in Paraná has an important one. I think that the strategy is to make the production reliable and find the best model is the key to have a production.
Very good, Joe. Thank you very much. Pelo. Okay, Brava's strategy involves reassessing its extensive onshore portfolio using the new GNG data. How do you prioritize which assets or basins to reinvest as a priority?
As I said before, it means prioritization means back to basics with state-of-the-art technology. So that's the only way we can unlock some additional reserves for Brava in those mature basins. And that's what we are doing now with seismic reprocessing, and we are going to do with basin modeling, and we are going to have all integration with wells and sequence stratigraphy, structural geology, and come back to a portfolio well integrated and ready to deliver drillable prospects maybe in 1 or 2 years. So it takes some time, cannot be done quickly, and things have to be, or activities have to be done in parallel. We cannot do the way we want it. But anyway, one thing that I'd like to add is to jump back into what Nubia commented about permitting. She made some comments on the wells and how long it takes to drill a well. I had made some studies together with BGP as well for seismic acquisition in Potiguar Basin, and it's amazing that licensing is something that makes almost impossible doing or shooting seismic again in the basin. The federal government just settled a lot of small farms, small properties in the whole Potiguar Basin. And for you to enter into a license in the Environmental Institute, IDEMA, you have to get signatures from all communities or small farms owner in these assentamentos, as you say in Portuguese, and go to INCRA in Brasilia and initiate a process that should require more than hundreds or thousands signatures. So imagine extensive seismic 3G, or it's really a nightmare, and it does not involve only the state, but we mean the federal law and government. So something has to be done, integrated, like Márcio said before, so that we can overcome all of these limitations for the onshore exploration.
Yes, hard, very hard. Yeah. So I believe that when you see all these restrictions in terms of environmental licenses, social license, etc., I think the only solution, when you look at the future, the only solution is to go and develop technology, non-invasive, that really can convince all stakeholders that you don't affect at all the environment. Otherwise, we have no future. Okay. Julian, please. A good one for you. What role do you envision for Petrobras in fostering collaboration and data sharing to stimulate onshore exploration by other operators?
So it's a little bit trick question. It's not that interesting because the responsibility.
Question, short answer.
Yeah. We know that Petrobras has a strong responsibility here in Brazil to promote the exploration in general. In the past, almost the complete responsibility for onshore base was for Petrobras. But nowadays, we strongly believe in synergy, as some colleagues said. We have a strong capacity to processing data. For example, we invest a lot in high-performance computer. We are in the state of art of technology, a lot of partnership with the services. We advance and involve a lot in this in other basins, so you can put this in onshore. But we think the responsibility to promote the onshore exploration again must be as a team. It's not more related to only Petrobras. We think the government has a lot of responsibilities. We need to involve the contractors, the regulation. How can you use the investments? For example, for Petrobras, it's very important to use the investments in R&D. So, for example, we have a lot of limitations to use these in mature basins. For example, we would like to invest again, for example, in acquisition in this area, but we can do this. We can do only in the new frontiers in onshore. So we can promote. We can help with our strong and capacity in Petrobras, but not alone. We strongly believe in synergy, and we can do this together.
Okay, thank you. Something that strikes my mind here when talking about exploration onshore, that obviously that the first thought is always the best seismic. We provide the best understanding of the subsurface, but sometimes, I wouldn't say people forget, but don't put the real focus on how airborne geophysics can help, easier to share with all players in the same area, and extract the most of airborne geophysics. That's something that we should think more deeply. Okay, thank you very much. Thank you very much. We have 1 minute. Let's use 1 minute, okay? That's a long question, but please give me a very short answer. You can answer even with keywords. Let's go here. One moment. I prepared this. Jesus. Thank you. Okay. A pergunta a partir das diferentes perspectivas de vocês, operadores, empresas de serviço e governo, como a geofísica sustentável pode contribuir para revitalizar a exploração onshore no Brasil e, ao mesmo tempo, gerar benefícios sociais e ambientais concretos para as comunidades locais? I will repeat this in English. Across your different experiences, from operators to service companies and government, how can sustainable geophysics contribute to revitalizing Brazil's onshore exploration while also delivering tangible social and environmental benefits to local communities? So the main reason for this question is to be, very in synergy with the main theme of our Congress. Ok, let's começar com a Anúbia, pode ser?
Yes. Okay, the example which I had is when I drill one well to explore a 3D area with different arms, for example, for the well. Is a good example too.
In a very key words, I would say non-invasive exploration. Say technology, mindset, digitalization, everything that you have, all the thousands of wells that have been drilled, all the cores that are still to be organized. So we have a lot of data in Brazil, and the Petrobras goodwill, say, again, another key word, and then all together we can have better results. And the footprint for onshore has a coincidence with the social and environmental cares that we need in Brazil. So just to explore where the bases are.
Keyword. All of us, we need to think the data, seismic data, whatever the geophysics can contribute, is an asset, is an investment, is not an expense. And that is really important to convince all decision makers that today they're looking at the geophysics or any geoscience area as a just simple, again, something that they have to spend and no value add. This is the last message.
Okay, actually, as from the data side is a support for the development. So once we have a discovery, once we have a development, we're gonna change the community and the region that the onshore is acting. But a seismic crew like those ones that I showed before, involving thousands of people, is a beginning of some years before a development, is a beginning of an investment that can supply, it should be supplied by the community. So imagine that per day in an Amazon campaign, the protein is about 1.2 thousand of ton per day. So it's a crew with about 1,500 people, 1,500 people. So it's a lot of suppliers involved to have this crew in the field.
Well, keywords for onshore exploration, I believe it's technology and human resources. And for the local communities, I think that's a generation of jobs and services, like Diogo has just said. So this is the most important contribution of the geophysical work in some of the poorest areas in Brazil, where we can really do something in addition for the richness of the state or the people socially.
Okay, just a few words to say that we need to involve the society and be more transparent. We think that we need to explain that we are not here to do a traditional oil and gas exploration production. We are in charge of the sustainability, we are in charge of the security for the future, for the society. So, and we are in a moment with a lot of pressure without all the information. We think this is our main challenges for the future. Thank you very much.
Perfect, Stika. Thank you very much. Yeah, I think you should finish with a keyword: energy security. That's a real important. Well, guys, thank you very, very much. That was a wonderful panel. It's going to be recorded on YouTube. I'm quite sure that we have a huge public outside, and everybody can review. Okay, so you create a very important content regarding the onshore exploration for sure. So thank you very much. Okay, applauses for our panelists, please. Well, let me give you one invitation here. Something very important is happening to the Brazilian geophysical community today, okay? So you'll be celebrating somehow the regulation of the profession. And you have one congressist that was key, very important to achieve this goal. His name is Chico Alencar, okay? So he's going to be in the panel in the Petrobras room, okay? And please join us to celebrate this moment. There will be a panel, a social panel. You can discuss what is the title? Consciousness in Science. It's very interesting. Also, to commemorate this special day, which is o Dia da Consciência Negra, okay? All right, thank you guys, thank you very much.